Hey everyone, Mr. Newman here. Today we're going to learn about part 2 video on parametric equations. This is just going to be a little bit of follow-up to the previous video. Just as a reminder, the parametric equation is a function with two output values and a hidden t variable. And that t variable is the input, if you remember that. So what we're going to learn about today is going between our usual x and y function notation and parametric equations, going back and forth between those. So the first thing we're going to do is we're going to do this thing called eliminating a parameter, meaning we're going to take a parametric equation and rewrite it so we don't have any t. It's just in terms of x and y. So there are three steps here, aka eliminating t. The first step is going to be we're going to solve for t in one of the two equations. Then we're going to substitute it into the other equation. And lastly, we're just going to need to simplify it until it looks like something that we can recognize, say a parent function. Well, between these two here on the right, I'm going to choose the equation on the right, y equals t over 2. The reason for that, there are a few reasons. First of all, it looks simpler, so it'll be easier to solve for t initially. Secondly, since it doesn't have a squared, x squared term, that squared we would have to square root, and anytime you square root an equation you have to worry about plus or minus. So instead of we're having to worry about two separate equations, at that point we're just going to solve for the one on the right, so we don't have to do that. So we're going to solve for t, multiply by 2 on both sides, and we get 2y equals t. Now I'm going to take that and substitute that back into the other equation. Since 2y is equal to t, instead of t, I'm going to write 2y squared. So x equals 2y squared minus 4, and then we have to simplify it, so we get x equals 4y squared minus 4. Notice that right there is an equation. It does not have t, and it's not written in terms of y, so it's not a function per se. This is not a well-defined function in terms of x and y here, but the original parameter is. So what I want to do, I'm going to graph these side by side so you can see them. The one on the left is the parametric. The one on the right is x equals 4 times y squared minus 4. Notice that they cut out the same space. Now the one on the left, the parametric, that goes from 0 to 4. I could have graphed it from, say, -4 to 4 or -5 to 5, and you would see the same graph as the one on the right. I just wanted to show you where 0 starts. The parametric also has a direction to the path, whereas the other side does not. And the one on the right is also not a function. Even if the one on the left covered from -4 to 4 and cut back and forth, it actually would be a function because it has one input, that t value. But here on the right, since we're not solved in terms of y, the input is technically the x's and the output's the y's, and that's not a well-defined function. So it's kind of weird that you have the same shape, same graph, but the two things on the two sides, one is a function and the other one is not. All right, moving on, I want you to try the next one. All right, this was a little bit trickier, but if you followed the steps and followed your algebra, you would have done just fine. I chose the one on the right again, so we wouldn't have to deal with a square root at first. So let's solve for t here. We need to multiply both sides by t plus 1. Then we're going to distribute the y. And I need to factor out the t to get t by itself, and we divide by 1 minus y. So we get t equals y over 1 minus y. Now that I have that, I'm going to substitute that back in for the other t in the other equation. When I plug that in, it looks kind of like messy, and we can't tell what it is, but let's start simplifying some of the algebra and we'll see what happens. So we get, on the inside there, I found a common denominator. And I can combine them. Notice there's a y and a negative y. Those are going to add up to 0. And the square root of a fraction, you can just take the square root of the numerator over the square root of the denominator. And now, dividing by the reciprocal, you get x equals the square root of 1 minus y. Now that's not in terms of y, so let's take a step further and solve it in terms of y. But notice, because I squared both sides here, I need to beware. On the bottom, x can only be positive because it's a square root function. So I'm going to say x must be greater than or equal to 0. So that's fine there. And when you graph this, you get, that's a quadratic. Y equals 1 minus x squared. Of course, we can't have x being negative, so it's actually just the right side of that graph. But that big messy parametric is now in terms of something we can recognize and can graph more easily. So, yeah, right there, y equals 1 minus x squared. I would encourage you on these to graph these either on your graphing calculator or on Desmos in order to check them and make sure what you have is what you thought would happen. So, the other thing we need to worry about is we need to know if we have a function in terms of x and y, can we write it as a parametric? Now the problem with that is there are an infinite number of parametrics for any function because you can define t going at any speed, at any velocity, and you can even have it going backwards. We're going to look at that in a second. So there's an infinite number of parametric equations. So what we have to do is they have to give us at least one more bit of information. For example, give us t in terms of x, which is what they do here. So the function is y equals 1 minus x squared, and they say find a parametric equation if t equals x. We're going to do the same problem on the right if t is a little bit different, and I'll show you how the different result actually ends up with a function that's equivalent, but gives you a different set of parametric equation. So that t equals x is going to be useful because what we're going to do is we're just going to substitute t in for x since they're equal. So instead of x there in our original function, I'm going to put the t, and now we can write our parametric. X is equal to t, and y is equal to 1 minus t squared. Done. It's pretty straightforward if t is equal to x. If it's not exactly equal to x, we first need to solve for x. So on the right here, that's what we're going to do. Let's solve for x in the t equation. And so we get, if we add x to both sides and subtract t from both sides, we get x equals 1 minus t. Now we can solve that back into the original function. Y equals 1 minus, and instead of x, we're going to put 1 minus t, that quantity squared. So we're going to simplify that, and I'm going to write these out. So we already have x is 1 minus t, that's the first one. And the second one, when you simplify and rearrange it, you get negative t squared plus 2t. Now let's talk about these before we move on here. For one thing, do you notice how this, and this, those three starred, are all three different representations of the same function with slightly different things going on. First of all, the original function is not a parametric, so it doesn't have a direction. It's simply the graph. This parametric equation here, the first one, notice x equals t. So as you move left to right on the graph, time moves forward, marching at the same pace as x. Very simple and straightforward. However, the one on the right here, x equals 1 minus t, does a few things. First of all, the 1 means your parametric situation is going to start in a different location. When t is equal to 0, x is actually going to be positive 1. It's going to start in a different location than the other one. The other thing is that this negative t here means that time is moving backwards when compared to this first parametric equation. So if you graph these, one of the functions cuts out the curve going one direction, and the other one cuts out the curve going the other direction. And I would encourage you to graph both of those. I left graph paper here for you. Graph both of those so that you can see what I'm talking about, how one goes in one direction and the other one moves in the other direction. And those are both giving you the same original function, but traveling the path in different directions based on that original t that was given to us. All right, go ahead and try this one on your own. All right, first one should have been pretty quick. Y equals t squared minus 5. So we have x equals t, and y is t squared minus 5. On the right here, we first need to solve for x. So I'm going to get, when you add x to both sides and subtract t from both sides, you get x equals 3 minus t. And then plugging that in for x, we get y equals 3 minus t quantity squared minus 5. So when you start to simplify it, we're far enough now, we can write the set of parametric equations, and we get x equals 3 minus t. That's the x parameter, x function, part of the function, and then the y part is t squared minus 6t plus 4. Once again, this original function and these two parametrics should give you the same graph. So go ahead and graph them, and see if you can figure out what does the 3 do on that second parametric equation. Thank you very much for watching.